over here. Let's say I have the mirror in which you look at yourself every day. This is the normal of the mirror, and here comes an incident light at some angle I. I'm going to call the angle of incidence with respect to the normal. With respect to the normal means that I am measuring it not from this surface, which means that I am not measuring this angle. I am measuring this angle. That is what it means to be measured with respect to the normal. So if it is I with respect to the normal, and if it bounces back at an angle R with respect to the normal, then angle I must be equal to angle R. That is the first law. Now, the second law of reflection states that the incident ray the reflected ray and the normal at the point of incidence all lie on the same plane. If you are not familiar with what is meant by a plane, then you might not get this point. Let me make it clear. So any flat surface that you see is known as a plane. For example, I have this envelope over here. This itself is a plane. It is a flat surface, and there are infinite planes in a space. So this position, the position of this flat surface is known as, let's say, plane 1. Now if I tilt it to some angle, this position of a flat surface is known as some other plane, say plane 2. So let's clarify this point further. Let's say that the surface of this board, the very flat surface of this board, is a plane that I am talking about. Now assume that this is an incident light. Here it comes. Now the very surface at which it has come, I will in my mind draw an imaginary normal. Let's say this is the imaginary normal and this is the incident light. Now these two themselves create